My name is Sobi Yamamoto. I'm a second-year master's student at Keio University. Today I'll be presenting on my research, PuzMaty supporting puzzle mat design creation. A puzzle mat is a cushion mat surrounded by puzzle-like edges. It's widely used in living rooms and spaces with small children like kids area to protect them from injuries like falling over and reduce noise. Puzzle mats are especially common for children as they provide a safer environment for play. Most puzzle mats are between 30 cm and 1 meter on each side and can be combined freely, making it easy to adjust their size and shape to fit any type of the room. In 2022, the market size for playmats. In this case, playmats refer to a variety of mats for children, including puzzle mat. The market size for playmats was about $1 billion, and compound annual growth rate is expected to be 6.9%. By 2029, the market is projected to expand to $1.5 billion. Recently, puzzle mats with numbers or letters like the one shown in the image above have become available. These mats are not only used for safety purposes but also for educational purposes, helping children learn while playing. On the other hand, there are several challenges with current puzzle mat. First, when purchasing, it's necessary to check the appropriate size and number of mats for the space. Additionally, puzzle mats are often sold in 2 or 3 colors, which tend to lead to simple layout, like the checkerboard pattern shown in the image on the right. When arranging the mat with specific designs like animals and symbols, it's necessary to adjust the number of mats of each color to create the design, which can be time-consuming. This complexity is one of the reasons for the simplicity of typical layout. In this study, we developed a design creation support tool for puzzle mat named PuzMaty. This tool will allow users to simulate the layout on a computer before placing the mat, making it possible to calculate the appropriate mat sizes, colors, and quantities needed before purchase. Additionally, users who already own puzzle mats can easily redecorate with them, thus expanding design possibilities. This will give puzzle mats, traditionally used for child safety, are worn as an interior decoration that adds color to the floor, and is expected to promote room makeovers. I will now introduce related research on design support tools. Creating design plans for handicraft required specific skills and time. However, this method allows children and beginners to easily create handicraft projects by generating design plans based on illustrations or 3D models, making the process fun and accessible. In addition to converting designs into blueprint, there are also studies that support during production of the knitted or embroidered work by correcting design plans without the need to undo stitches when mistakes are made, as shown the figure above right. Other research explores converting 3D models of Lego blocks to achieve the most stable structure. Next, I will introduce research related to floor coverings. Regarding carpet design, there is research on graffiti floor, which utilizes the traditional pile of carpets to create a display. As for the interaction between mats and children, studies have been conducted on the use of carpets for rehabilitation of children with cerebral palsy, focusing on lower body therapy, as well as the use of carpet in training for children with autism. This is the flow of the proposed method. The proposed method is divided into 3 steps. First, the user scans a 3D model of the environment where they want to place the mat. Next, the model is imported into a system implemented in Unity, where the user can freely design by adjusting the sizes and colors of the mat. Finally, based on the created design, the user places mat in the actual environment. As I mentioned on the previous slide, this system, PuzMaty, is implemented in Unity. A 3D model scanned with an iPhone is imported into the system, and the user preprocesses, including flotation of the models, definition of the matte placement area, and adjustment of the matte size. This section explains the system structure and the method for detecting furniture. PuzMaty is composed of 3 layers: the 3D model layer, the matte layer, and the point cloud layer. Both the matte layer and point cloud layer are made up of smaller matte. The matte layer visualizes the placement of puzzle mat for creating designs, while the point cloud layer is constructed with even smaller matte to detect specific areas of point cloud within the 3D model. Areas with obstacles such as furniture and walls tend to have concentrated point clouds, so each matte within the point cloud layer corresponding to these areas becomes active. When more than 60% of the point cloud layer beneath a single matte in the matte layer is active, it is determined that there is an obstacle at that location. The matte in matte layer is then grayed out, allowing the user to avoid placing matte where there are obstacles. This is an example of the design creation process. The target users of this system include those who already own mats and wish to rearrange them within a limited number, and as well as users who do not own mats and are considering purchasing them. For users who already own mats, as shown in the video on the left, they can register colors and quantities of mats they already have and create designs without exceeding the number of mats they own. On the other hand, for users who don't own mats, they can freely create colors while creating designs and purchase the colors and quantities used in the simulation. After the design is complete, the user arranged puzzle mat based on the created design. To evaluate the effectiveness of the system, an experiment was conducted to create designs using this system and place puzzle mat in the actual environment. The experimental environment used the room shown in the picture, and in advance a total of 224 mats in 6 colors: beige, orange, green, yellow, blue, and brown were prepared to match the dimensions of the room. The experiment involved 10 participants, consisting of 6 males and 4 females. Initially, participants were asked to check the available mats and register the colors and quantities. For the design task, no specific challenges were set, and participants were encouraged to freely draw designs. These are the designs created by the 10 participants and how the mats were placed. As shown in the top row, many participants drew animals, and others drew plants and characters, and so on. The participants were asked to complete the System Usability Scale (SUS) to evaluate the usability of the system, and the average score was 82.5. Since the average score for SUS is 68, this suggests that the system is useful for creating puzzle mat designs. Additionally, interviews with the participants were conducted to assess their satisfaction. Most participants reported that the designs created in the system matched the arranged designs in the actual environment. However, one participant mentioned that during the process of registering matte colors, he created a different color than the actual matte, causing a discrepancy between the simulated and actual designs. Other feedback included that the easy simulation process encouraged matte rearrangement and that the system made it easier to place the matte without confusion. Regarding future work, improvement to the interface will be made based on feedback gathered from participants after the experiment. Additionally, new features should be added, including design suggestions and support during matte placement. In the current experiment, 8 out of 10 participants referenced images when creating their designs. This suggests that some users may find it difficult to design from scratch. To make the design process easier, we plan to create a design dataset and implement a feature that suggests designs based on images or keywords that the user input. Another idea is to provide a function that converts the image into pixel art or suggests designs from color and number of mattes by using generative AI. Furthermore, currently users either place the matte by checking the printout of the created design. To improve the efficiency of the matte placement process, we aim to add a feature that displays the colors of matte to be placed at specific locations through AR, as well as a function to show the sequence in which matte should be placed. Here is the summary of my presentation. Thank you for listening.